All right, so let's go over some conversion practice again, stuff that we were looking at last week. So this first one. So real quick, remember, moles is in the middle. All right, always got to get to and from the mole. All right, how many moles are 180 grams of potassium sulfate? So we're going to write out 180 grams of potassium sulfate. All right, so we draw our H. The unit grams of potassium sulfate has to go at the bottom. And we can link grams to moles of anything. That's an allowed thing. And the way we link them together is that 1 mole of any substance is equal to its molar mass. And we're going to get its molar mass from the periodic table. All right, so we're going to do the molar mass up here. So molar mass. All right. Well, potassium is 39, but there are 2 of them. That's 39 times 2. Sulfur is 32, and then plus 16 times 4, because there are 4 oxygens. So if we do this math, all right, we're going to get 174 grams. So there are 174 grams of potassium sulfate in 1 mole of potassium sulfate. And now to solve, all right, these units cancel out. We're left with the right units. Because they're on top of each other, we divide 180 divided by 174. And we have 1.03 moles of potassium sulfate. All right. Okay, let's look at a different one. Okay. 3, how many formula units? Same thing as saying molecules or atoms. All right, same thing as saying that. All right, in 75 grams. All right, this is a good one. So we're going to start with 75 grams of nitrogen. Now, we're trying to get to this, all right, aka the atom, but we cannot directly go from grams to atoms. So we're going to put grams of N2 at the bottom. And just like we did before, we can go from grams to moles if we use the molar mass. So 1 mole of N2 is 28 grams. Each nitrogen is 14. 14 plus 14 is 28. Grams of N2 are done. We have moles of N2. We don't want the answer in moles, though. We want to get to formula units or atoms. Well, 1 mole of anything, in this case of N2, is 6.02 times 10 to the 23rd atoms. All right. Now I'm going to solve this doing it without typing in scientific notation into my calculator. So we're going to do 75 times 6.02. And then we're going to divide that by 28. And you get 16.125. And then we do times 10 to the 23rd. Well, this number is not okay. We're going to move this decimal 1 over here. And now it's 1.6125. And we got to make the number 1 bigger, so it's to the 24th. Let's look at 8. All right. We have 67 liters of N2O5 STP. We want to find out how many molecules are in there. All right. So we're going to start with 67 liters of N2O5. We're going to put liters of N2O5 at the bottom. Now, again, our goal is to get to molecules or atoms. We cannot go from liters to molecules. We can go from liters to moles. When we're at STP, 1 mole of any gas at STP is 22.4 liters. All right. Well, now 1 mole of our gas of N2O5, 1 mole of anything is 6.02 times 10 to the 23rd atoms. All right. And now, again, we're doing the same thing again. We're just going to solve. So I'm going to do 67 times 6.02 divided by 22.4. I get 18, basically 18 times 10 to the 23rd. Well, that's no good. I got to move the decimal 1 place to the right. I'm sorry, 1 place to the left. So I get 1.8. times 10, and remember this number one bigger, 24th pounds. All right, guys, good luck.